Now in this tutorial today we'll be looking at how to find the relation between A and B without involving logarithm. And we're told that if log A base 4 equals log B base 8 plus 1. So how do you go about it? Okay, let's get started. Now let us have it here that log A base 4 equals log B base 8 then plus 1. Okay, now first of all, since our final answer mustn't have logarithm, so definitely we'll find a way to ensure that we eliminate every logarithm in the equation. So first of all, let's make log A base 4 x. So let's say log A base 4 equals what? X. So our new equation becomes x equals log B base 8 then plus 1, right? Now since here we have 1 here and this log here is 8, so we can actually say here that this is log 8 base 8. Okay, all right. Now whenever a log the argument of a log and a base is the same, then it equals to 1. Alright, so and according to the law of logarithm, okay, when you have log A plus log B, now this is log AB, where the argument multiplies. Okay, so here x now becomes log 8b base 8. Okay, alright, so let's undo or eliminate this log. And how do we do that? Now let us recall that if you have log AB equals C, okay, we can actually transform this logarithm into index by saying this B, our C here will now be an exponent to B. So here we have that A equals what? B raised to what? C. Okay, so in this case now, it means here that, take note, our A here is 8b, our B here is 8, and our C here is what? X. So which means that B, which is our 8 here, will now have that 8 raised to x, then equals to what? 8b. Okay, alright. So here we have it now that we've now undo or remove the log. So let us come back here for log A over, log A base 4 equals x. Log A base 4 equals x. Applying this rule here, so we can say here that our A is our A here, our B is our 4, and our C is our x. So it means that our A, which is our A here, then will be equals to then B, which is our 4, we have 4, then raised to x. Okay, so we can now write it as that 4 raised to x equals what? A. So let us assume this is equation 1 and this is what? Equation 2. Now the question now is, how then do you find a relationship, one equation that connects both A and B? Okay, from let's reduce 4 to a base of 2 and 8 to a base of 2. So we end up having 2 raised to 3 all raised to x, then equals to 8b. Then for equation 2, we have 2 raised to 2 all raised to x, then equals to what? A. Alright, now I can get a common exponent for both this equation and this equation. Okay, let me do this. I want to raise this one to 2. I want to raise it by 2. Okay, and I will raise this by 3. And why? So that I could get a common exponent for the two of them. Okay, now let us do this. So here, let's raise this by 2, which means we'll also raise this by 2 to ensure equality. And here by 3, here 2 by 3. Okay, and according to the law of indices, all we just need to do, this exponent multiplies each other. So we end up having 2 raised to 6x then equals 64b squared, because 2 will be distributed to 8 and b, and 8 raised to 2 will give us 64, and b raised to 2 is this. So for the next one here, now since everything 2, take note, 2 times x times 3 will give us what, 6x, then equals 8 raised to what, 3. So we've now arrived to a common term between the first equation and the second equation. You can see here you have 2 raised to 6x, and here you have 2 raised to 6x. So which implies that if 2 raised to 6x equals a raised to 3, we can also say that here a raised to 3 equals 64, b raised to 2, right? So we can now agree that a cubed equals 64b raised to 2. So I guess that is all. Yes. So the relationship between a and b without involving logarithm is this. Please don't fail to share this video to every other learners, and don't also fail, if you are new to my channel, to subscribe and to like, also to follow. Thank you and remain blessed. Bye bye.